Hello everyone, in this video let's discuss about SR latch construction using NOR gate. So what is NOR gate? NOR gate is the combination of OR gate with NOT gate. This NOT gate will complement the values. That is, it will convert 0 to 1 and 1 to 0 when the input is given. If we want to write the truth table for NOR gate, first let's write for OR gate, then let's convert to NOR gate. So A and B are my inputs that I am taking and Y will be my output, that is OR gate output. Since I am having two inputs, my possible combinations are 0, 0, 0, 1, 1, 0 and 1, 1. So what OR gate tells? Either of my inputs are equal to 1 means my output will be 1. If here 0, 0, so 0. Either of the inputs are equal to 1, output will be 1, 1, 1. Now if you want to convert it to NOR gate, you will be adding NOT gate in front of it. What NOT gate does? It will convert 0 to 1, 1 to 0. Now if you see the NOR gate outputs, you can tell that if either of my input is equal to 1, my output will be 0. That is, at least one is there in input side, then 0 will be my output. 0 will be my output. At least 1 will be acting as a input. At least there is one higher bit, that is 1 in the input side, means output side will be equal to 0. Now let's construct the SR latch using NOR gate. So this is the representation of NOR gate. We will be using two NOR gate to construct. My output will be Q and Q bar, same as the all the flip flop and latches will be having only two outputs, Q and Q bar. You can use any of the alphabets to represent it, A bar, B bar, like that. But both these output must be complementary to each other. That is, if it is 0, this must be 1. If this is 1, this must be 0. Both cannot be same. 0, 0, 1, 1 is not allowed. So this will be S, this will be R, and output of one NOR gate will be acting as input to another, and output of another will be acting as input to another, like this. So here we constructed. Now let's write the truth table for SR latch using NOR gate. So S and R are my inputs and Q bar are my outputs. Now if you see, two inputs are there, so possible combinations are 0, 0, 0, 1, 1, 0 and 1, 1. Now when you apply 0 and 1, S value is 0 and R value is 1. We concluded that if at least one of the inputs is 1 means my output will be 0. At least one of the input is 1 means my output will be 0. This 0 is coming because of the presence of this 1 as the input. So you must write in front of that one only. So if you write 0 here, this will be acting right here as the input for this NOR gate. 0 and 0. 0 and 0 means my output will be 1. So Q value is 1 and Q bar value is 0. So you can tell that both my outputs are complement to each other. So this is satisfying the condition. Now let's move to the second one. That is S value is 0, R value is, that is S value is 1 and R value is 0. Now if you see, there is the presence of one higher bit, that is 1 as the input. So you can tell that output will be 0 and this output will be acting as an input right here. When both the inputs are equal to 0, my output will be equal to 1. Q value is 0 and Q bar value is 1. Both of them are complement to each other, so they are satisfying the condition. Now let's move to the first one, that is 0, 0. S value is 0, R value is 0. When both my inputs are equal to 0, output will be 1. So you can write 1 here or here also. So this one will be acting as the input right here. This one 0 is my one input and 1 is my another input, which came as the output from this NOR gate. Now 1 and 0, at least one higher bit is there means output will be equal to 0. 1 and 0. Q value is 1 and Q bar value is 0, which is already in memory. So you can write in memory. No need to write them repeatedly. Now the last condition is 1 and 1. R value is 1 and S value is 1. When both my inputs are equal to 1, output will be equal to 0. You can write here also, here also. So this output will be acting as the input to this NOR gate, and 1 and 0. If one higher bit is present, then my output will be equal to 0. So both my outputs are equal to 0. Q is 0, Q bar is 0. Both my inputs are 0 means this is not satisfying the condition. That is, both my inputs must be complement to each other, 0, 1, 1, 0 like that. But here the same output is coming. So you can tell that this is invalid. This is invalid. So this completes the SR latch construction using the NOR gate. If you have any doubt regarding this topic, please do comment below. I will clarify it. If you liked the video, please subscribe and support us, because your one support motivates us to make more engineering related videos. Thank you.